In this lecture, we are going to discuss about harmonic function. First is definition of the harmonic function. Any function of x and y possessing continuous partial derivative of first and second order and satisfy Laplace equation is called a harmonic function. That is, if f is my function of fxy possessing continuous partial derivative of first and second order exists and continuous satisfying Laplace equation, then f is harmonic function. Next is a theorem. If fz equal to u plus high v is an analytic function, then u and v are both harmonic function. Proof: let fz equal to u plus iv be an analytic function. Then it satisfy Cauchy-Riemann equation. That is, if u and v are real and imaginary part of an analytic function f z, then it satisfies Cauchy-Riemann equation. This is 1, and del u del y equal to minus del v del x. This is 2. Since u and v are real and imaginary part of an analytic function, therefore therefore partial derivative of u and v of all order exist and are continuous function of x and y. Are continuous function of x and y. Continuous function so differentiating one partially with respect to x, you will get this is del 2u del x2. Here in the right hand side it is del 2u del x del y. Okay, so this is del x of del u del x. Here in the right hand side del x of del p del y. This will implies del 2u del x2, and here it is del 2p del x del y. Put this equation 3. Again differentiating 2 with respect to y, we will get this is del 2u del y2 here minus del 2 del y del x p. So del y del u del y minus del y del p del x. Then right here differentiating 1 partially with respect to x, we get again differentiating partially, differentiating 2 partially with respect to y, we get this implies del 2u del y2 minus del 2p del y del y put this equation 4. Adding 3 and 4, we get 3 plus 4 implies, now add this to equation, add this equation with this equation, that is left hand side add with left hand side, right hand side with right hand side, we will get this one. Del 2u del x2 plus del 2u del y2, that is del 2b del x del y minus del 2p del y del x. Using Young's theorem, that is if V possesses partial continuous derivative, if he possesses continuous partial derivative of first order, second order, then this happen del 2b del x del y is equal to del 2p del y del x. Therefore del 2u del x2 plus del 2u del y2 is equal to 0. Similarly, we can show that del 2v del x2 plus del 2v del y2 is equal to 0. Similarly, we can show that del 2v del x2 plus del 2v del y2 is equal to 0. This implies u and v satisfy Laplace equation. Hence, u and v are harmonic function. We are harmonic function. Harmonic function. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.